Hi guys, Physics Chapter 3, Module 3, we're talking about two-dimensional vectors. We've talked about this briefly in previous lectures, but I just want to remind you that in the first two chapters, when we were talking about motion, we were talking about one-dimensional motion, where you might have a car and it is going this direction, and then it has a negative acceleration of this direction, but you're still only talking about one-dimensional. Or you might have a case where you throw a ball up in the air, and then due to the acceleration due to gravity, it comes back down, but you're still just talking about a one-dimensional plane. But now what we're going to start talking about is two dimensions, like on an XY coordinate system. So if you were to travel from this point and go 1.2 miles, say to the east, and then travel 4.3 miles to the north, somebody might want to say, what is the resultant vector? And remember, we go tail to tip as we're adding the vectors together. And this resultant from the beginning to the end point is the resultant of those two in that two-dimensional vector. The two main formulas that you need to know is that the magnitude of this vector here, if we call it A, then this here, this vector in the x direction would be the x portion, and this would be the y portion component. So you have the x component and the y component, and the magnitude of vector A equals the x component squared plus the y component of vector A squared, and you take the square root of that. And that's going to be the magnitude of A. So that's your first equation, and that's on page 79 at the bottom, equation 3.2. But remember, since it's a vector, you don't only need the magnitude, you also need the direction, which we can represent by the angle of this resultant vector, which we will call theta. The formula you need for that is at the top of page 80, and that angle theta is equal to the inverse tangent of the y component of A over the x component of A. And when you find that, that'll give you the direction of that resultant vector. Okay? It's important to note that in your XY coordinate system, you always start at your positive x-axis and go in a counterclockwise motion to measure your angle, okay? So in that case, that angle might be 60 degrees, for instance, because you're measuring it from that point, okay? If you recall the experiment that we did in class 2 weeks ago, we did the experiment where you had the ruler, where we measured a pencil that we had held up with silly putty or something, or clay. And we used that ruler, and we did two different calculations to find this theta and to measure the length of this resultant vector. And then we actually measured that angle with a protractor and measured the length of that pencil with a ruler to see the difference between calculated and measured distances. So that's experiment 3.1 that we did a couple weeks ago. The next thing I want to cover starts on page 85. And this is going to move into our experiment that we were supposed to have done Friday. And I'm going to go over that experiment with you really quick too, so that you can do it at home, so that everybody's caught up. What you need for this experiment is at the bottom of page 85 in your book, if everybody could turn there. You have two equations. The y component of a vector can be found by multiplying the main vector, magnitude, times the sine of theta. And the x component can be found by taking A times the cosine of theta. Those formulas are at the bottom of page 85. And that's when you have this type of a scenario. You have A in the x direction, the y component here, and then this resultant A right here. And this is theta. Okay? So the only other thing we need to do is the experiment. I think y'all are all caught up. We did talk about briefly that when you add vectors, you find, say you're wanting to add an A vector and a B vector, say you have a B vector over here that's doing something different, like this or something, and this is B. If you want to add vector A and vector B, you're going to find the x component of B and the y component of B, and you're going to separate that out and make a two-dimensional problem basically two one-dimensional problems. So to do that, you're going to add A, the x component of A, and the x component of B. And see, in this case, since A is going this direction and B is going this direction, they're going to cancel each other out because they're opposing each other. Same within the y direction. A in the y direction is going up, B in the y direction is going down. So to add them, you just do all the x's together and all the y's together. So we'll see that in our experiment. So what I need to do for y'all to do next is to go onto your email that I sent you. You can pause this video, and I need you to print out this piece of paper right here. I sent this file. It's a map of the United States, and you're going to need a printout of that to be able to do your experiment. So if you could go now and print that, and then when you get back, push play on this video, and I'll show you how to do the experiment. You're going to need a ruler, a pencil, and a protractor. If y'all don't have a protractor, I don't know if you can run to store and get one, but you will need it for this experiment. Okay, so on your map, there's a scale, and the scale on the map you have should say 1 centimeter equals 180 miles. The one in the book is actually in centimeters and kilometers, but the map that I'm giving you is in miles. You're going to draw a line on step 3 from Phoenix to Bismarck. So take your map and use your ruler, and from Phoenix, you're going to draw a line to Bismarck. Like that. This is going to represent the displacement vector for the first leg of a hypothetical journey. But we have to also, besides just having magnitude, we need to have direction. So put an arrowhead here because we're going from Phoenix to Bismarck. Okay? Then you're going to measure the length of the arrow and convert it from centimeters to miles. So measure whatever the length of that is, and then convert it using this conversion factor and change it into miles. And then you know how many miles it is from Phoenix to Bismarck. Then, because it's a vector, we need to know not only distance, but we also need to know direction. So you're going to make an XY coordinate system right here at Phoenix. And you're going to use your protractor to find out what this angle is. Okay? Now you're going to draw another arrow from Bismarck to Washington, D.C. So now draw another arrow, and I'll do this in a different color. You're going to draw another line. This is the second part of your journey. From Bismarck to Washington, D.C. Again, you're going to measure the length of that with a ruler. Use this conversion factor to change that length that you found in centimeters to miles. And then at Bismarck, draw an XY coordinate system. Use a protractor and find the angle, keeping in mind that you have to start your angle from the positive x-axis, so it's actually going to be this angle. So it's going to be more than 90, 180, 270. It's going to be greater than 270 degrees. Do you see that? And then find that angle. Now that you have the magnitude and direction for both of those vectors, we're going to add them together. So, if you wanted to find out, you're going to do it two ways. You're going to do one with calculations, measuring using your formulas that I gave you in the last part. You're going to find the x-coordinate and the y-coordinate of this vector. And then you're going to find the x-coordinate and the y-coordinate of that vector. And you're going to add them together and find the resultant vector of those two. If y'all don't understand this, I can go over it in class on Friday. But try to see if you can do it by following the directions on page 91. And then after you've found that using the calculations and using formulas, the two formulas that I gave you that are on page 79 and page 80, you're going to use the protractor and your ruler to compare that resultant vector that you found by adding a vector plus b vector. And using those formulas, you're going to compare that to what you find by using a ruler and measuring what that length is and what this angle is. Because you're also going to find the two angles. Okay? So try to work through that experiment on page 91 and bring me your results, and we'll see how everybody did. So we will see y'all on Friday.